Hello, so we're going to look at dividing algebraic fractions today, 5.2. So we'll start with part 1, and the big idea here is an algebraic fraction. It's divided in the same way you divided numeric fractions. So just because we're throwing in variables, the rules haven't changed. All right, let's start with what division means and make sure we're comfortable with that. So here's just a visual to get you started. When 32 ounces of orange juice are shared equally among 5 people, each person gets 1/5 of a quart. So the idea of 32 divided by 5, to do that, each time we took 32 and we divided by 5. Each person got 1/5 of those 32 ounces. So each person got 32 times 1/5. 1/5 of that. So this is 32 divided by 5. This is 32 divided by 5. 32 divided by 5. So what's really important in all of this, though, is noticing that this idea, when you divide by a number, it's the same as multiplying by its reciprocal. That's the key idea with dividing fractions. Okay, so if we start with any fraction, just something simple like a divided by b, and we are going to divide by the fraction c divided by d. The rule for dividing fractions is to multiply by the reciprocal of what you're dividing by. So we still have a divided by b, but instead of divided by c divided by d, we're going to multiply by d divided by c. So then you get AD divided by BC. We can look at this with numbers. If we have 3/11ths divided by 5/7ths, instead of trying to do this division sign, we're going to take 3/11ths and we're going to multiply by the reciprocal 7/5. So 3 times 7 is 21. 11 times 5 is 55. So when you divide fractions, you're going to invert and multiply, or multiply by the reciprocal of what you're dividing by. So let's try an example. X divided by 4 divided by 3/5. So we're going to start off with our x divided by 4, our x fourths, and instead of divided by 3/5, we're going to multiply by the reciprocal 5/3. So notice that we flipped the right one, not the wrong one. So flip the right one, and we end up with 5x divided by 12, because x times 5 is 5x, and 4 times 3 is 12. Okay, we're going to move on to a little bit more complicated idea with division of fractions. We're going to simplify complex fractions. So a complex fraction, to get you started with what that means, a complex fraction is a fraction inside of a fraction. Let me write that out. So if I started off with 2/3 over 3/5, this is an example of a complex fraction because we have a little fraction and a little fraction, all with this big division sign that makes a big fraction. So it's a fraction inside of a fraction. Okay, but what's important to remember is this fraction bar means division. So don't let this be confusing just because it's a lot of fractions. I know we want to avoid fractions, but the reality is they're here, so we want to make sure we can work with them. So remember, the fraction bar means division. So even though we have this, it's the same as 2/3 divided by 3/5. So 2/3 divided by 3/5, if that way helps you think about it. So let's look at this algebraic fraction here. 6x over 5, all over, so we have a complex fraction, we have a big fraction, so all over 9x divided by 10. Sorry, I can't seem to make my line agree. 9x divided by 10. So let's rewrite this complex fraction using the division sign. Okay, so we have our numerator, the fraction 6x divided by 5. And instead of that big fraction bar, I'm going to rewrite that with the division sign, divided by 9x over 10. So not as bad when you look at it in this form. It's just a fraction within a fraction, which is division. Okay, so now that I've rewritten it with the division side, I can divide and simplify. So the rule for division by fractions is I multiply by the reciprocal of what I'm dividing by. So instead of 9x over 10, I have times 10 over 9x. So I'm going to multiply this. 6 times 10 right here. So 6 times 10 is 60. X divided by 5 times 9 is 45x. So now I want to simplify this. So I want to look for common factors, just like the previous lesson. So 60 and 45 both have a 15 in common. So 60 is 4 times 15, and then I still have x times x. And 45 is 3 times 15, and then I still have an x. So if I divide out common factors, the numerator and denominator both have a 15, and they both have an x. So I simplify to the fraction 4/3. So it started as a really complicated looking problem, 6x divided by 5, all divided by 9x divided by 10, just simplified down to 4/3. So when you were working with a complex fraction, let's try another one. Remember, a complex fraction is just a big division bar, so this fraction is just a big division sign. So let's rewrite this. So we have 3/8, our numerator, divided by 3/11. This fraction bar right there just means division. So 3/8 divided by 3/11. To divide fractions, we multiply by the reciprocal. So I take the reciprocal of the right one, invert and multiply. Oops, I need the reciprocal then. 11/3. And so when I'm going to multiply these fractions, you may notice at this step here that the 3's are common factors and divide out. So you get 11/8. If you didn't catch that, that's okay. You'll still get there even if you multiply first. 3 times 11 is 33. 8 times 3 is 24. Because when we break it down into those common factors, 3 times 11, 3 times 8, the 3's divide out, and we just end up with 11/8. The 3's divide out, and we just get 11/8. So when you simplify complex fractions, just be sure to treat fractions bars as division. So I'll leave you with this. Hopefully we can work with some fractions. It's the Peanuts cartoon. Now say we cut an apple in half. We have 2 halves, don't we? Now, how many of you ever felt like this when you're working with fractions? Just remember, the rules don't change even when there's variables. There's algebra. When you divide and multiply fractions, if you know the rules, they will work for all of them. Hopefully this helps.